Okay, so in this video, I want to give some intuition on the chain rule. I'm going to say something more formally about why the chain rule is true in class. So this video is just to give you an idea why it might be true. So the chain rule, the point of it is to be able to take a derivative of a composition of functions. So now we've learned how to take the derivative of several different types of functions, products of functions, quotients of functions, things like that. But we still need to know how to take the derivative of a composition of functions. So for example, here, if I want to take the derivative of square root of x squared plus 4, I know how to take the derivative of the square root function, and I know how to take the derivative of x squared plus 4, but when I compose these two things together, it's not clear what to do. Like, which rule should I use? It's not clear. So in order to do that, we need to use what's called the chain rule. And to visualize this, let's think about what's happening when we take a derivative. So I want to know how fast is this whole function changing, okay, as x changes. And so if it was f, if I was taking the derivative with respect to x of f of x, I would know how to do that. So I know how to take the derivative of f itself. And so if I understand how to take the derivative of f with respect to what's inside, so the independent variable is what I plug in, then I can use that intuition to understand what's happening here. So basically what I want to do is I want to understand how fast the what's getting plugged into into f of x is changing. So both of these things are going to be important. Let me give you some intuition for why that should be true. And for this intuition, let's just use a straight line with slope m. So recall that the slope is, you can think of it as the change in y over the change in x, right? And I'm going to rewrite this just to think about what the total change in y is. So I'm going to kind of multiply both sides and say that the total change in y is the derivative, the slope, times the total change in x. And so for example, if I tell you my slope is m, and I tell you x changes by 1, then you can tell me that y changes by m. That's what the slope means, right? It means if x changes by 1, then how much is y changing by? But if I tell you that x changes by 5, then, and I asked you how much does y change by, you would rightly tell me, you would tell me 5 times m, right? Because if x is changing by more, then y should also change by more, and it should be proportional, right? So if I told you x changes by 5, then you would tell me y changes by 5m. And similarly, if x changed by -1, you would tell me that y changes by -m. So there's a multiplicative factor going in. You multiply the rate of change times the amount that x changes. And so we can use this intuition to say how much is f of g of x changing as x changes. Well, we understand what happens, what the derivative of f of x is. And so if we understand how much is g changing, then we can understand the total rate of change, okay? So what I'm saying is that the derivative with respect to some variable, which I'm going to call star, of f of that variable, star, we understand that, right? This is just f prime of star. I know how to take the derivative, whatever f is, right? So say f is the square root function. I know how to take that derivative. And so what we need to understand now is how fast is star changing, right? So one way to think about this is that the total change in f, so what I want to understand is the total change in f over the total change in x, and then take the limit as the total change in x goes to 0. So I'm going to understand the total change in f, and the way to understand that is this is f prime of star times the total change in star, right? Times the total change in star. And now if what we're inputting to the function is g of x, so this star is g of x, then this means I have to understand the total change in star. And so I can understand that because I know the derivative of g of x is g prime of x, and this means that the change in g is going to be g prime of x times the change in x. And so this total change in g is this total change in star here, because g is what I'm plugging into the function f of x, right? So I can replace this total change in star by this term. So this becomes f prime of star times g prime of x times delta x. And now if I divide through by delta x, this tells me that delta f over delta x is f prime of this star function, so g of x, times g prime of x. And this is the chain rule. So this is telling me that the derivative with respect to x is this function. So I write this as the derivative of f of g of x. And so this is the chain rule, that if I want to take the derivative of a composition, what I do is take the derivative of the outside function and plug in what's happening to the inside function. And then I have to multiply by the derivative of g. So this multiplication of the derivative of g, how you should think of it is, it's telling me how much what's inside is changing, and that's telling me what factor to multiply by. So I'll give you a more rigorous reason why this chain rule is true in class, but for now, this is the intuition that you can use.